Hi, I'm Dr. Molly Mitchell, and I'm a researcher at the Virginia Institute of Marine Science. I work in the Center for Coastal Resources Management, where we study issues that affect decision-making. One of the things I study is sea levels and how they're changing over time. And today I'm going to talk to you a little bit about that. If you live in a coastal town, you might experience times when the roads are covered with water, like it is in this picture, and it can be hard to get around. If you've lived in the town for a really long time, you might feel like this is happening more frequently than it used to. And in many parts of the US, you'd be correct. To see how this has happened, we can take a look at water levels in Norfolk, Virginia. This is a graph where the bars show the number of hours where the water has been high enough to flood the roads in Norfolk since 1928. Between 1928 and 1960, flooding was a relatively rare event. In approximately 30-year time period, there was only twice that there was more than 50 hours of flooding in a year. If we add the data up through 1983, we see a little more flooding occurring, but it's still not a frequent occurrence. 1983 is the only year where we have more than 100 hours of flooding, and most years are below 50 hours. But look what happens when we add the most recent 30 years. All of a sudden, 1983 looks like a pretty good year. So what happened? Why has flooding increased so dramatically? Well, if we look at how water levels have changed in Norfolk, we can see that although average sea level has gone up and down from year to year, there's been an overall upward trend over time. And this trend is causing that increase in flooding. As it turns out, sea levels have been changing all over the globe. We know this because we've been measuring water levels for a long time. People have been measuring water levels in harbors around the world since the mid-1880s in some locations using tide gauges. In Norfolk, Virginia, the tide gauge has been measuring water levels since 1928. So we have almost 100 years worth of data. These tide gauges measure relative sea level rise. So it's a measure of how the water levels are changing relative to their previous levels at that place, that point. So it's the same experience a person standing on the land or a building which has been there since the 1800s would be experiencing. Since 1992, we've been measuring water levels across the entire surface of the globe using satellite altimetry. Satellite altimetry measures water levels relative to the center of the Earth. So what does this look like? This is a map of changes in water levels from satellite altimetry. You can see that water levels are changing everywhere, but different places are experiencing different changes. The average change for the whole globe is an increase in water levels of about 3.2 millimeters per year. However, in some parts of the Pacific Ocean, sea level is rising 8 to 10 millimeters a year. Well, up near Alaska, ocean levels are actually falling about 2 millimeters a year. What drives these differences in sea level change? Well, there are many different factors that affect sea level. Some of them work on global scales, while others work on very local scales. Let's take a look at some of the ones that impact sea level in Virginia. On the global scale, we have steric and eustatic sea level rise. Steric changes are due to increase in air and water temperature. As the water warms up, the water molecules become more active and actually take up more space. So this causes the water to expand. Even though there's no more water, it's now taking up more space. Eustatic changes are when water that was previously stored on land, so in glaciers, lakes, or aquifers, is released into the ocean. And this increases the amount of water in the ocean. So we both have more water in the ocean, and we have that same water taking up more space. Another large-scale process is ocean circulation patterns. In the Atlantic Oceans, water is warm in the tropics, travel northward to the pole, where they cool, become more dense, and sink. The cold water returns to the tropics along the floor of the ocean. A part of the circulation pattern, which we call the Gulf Stream, passes near the coastline of Virginia. As the Gulf Stream passes by Virginia, it pulls water offshore and carries it north, Over time, the Gulf Stream since 2003 has slowed and moved offshore. As it's slowed and weakened, it doesn't pull as much water offshore with it as it used to, so that water is staying piled up along our shoreline. Another process is land subsidence or sinking. This can be caused by large tectonic processes or where water is removed from the ground from like an aquifer, which causes the sediment above it to collapse downward. Both of these processes are occurring in Virginia and causing about 1.5 to 3 millimeters of land subsidence a year, depending on where you live. So what does this all mean for Virginia? We already saw a graph of how sea level had changed since the late 1960s. We can use that information to forecast future changes. When we extend the historic trend forward, we see that sea level will rise an additional 0.49 meters, so a little more than 1.5 feet in the next 30 years. Remember though, in the past, although water levels trended upward, they did vary from year to year. This will continue in the future. So even though we are showing a straight line, water levels will actually look more like this. Those two dotted lines are the bounds of the upper and lower variation that we expect to see in sea level. What if you don't live in Virginia? The sea level report cards on the VIMS website cover most of the US coastline. Visit the site to see how sea level is changing in your town and which processes are driving those changes. Increased sea level rise raises all kinds of other questions, like when we expect flooding to occur, how much flooding we expect to see, how can we protect our homes and our cities from damage? In Virginia, we've created a website, Adapt.va, to help answer these questions. Take some time to visit and explore the site and see what you can learn about reducing flood impacts. The site has lots of examples of flood adaptations, like this flood-proof building that we have here at VIMS. Even though this building is surrounded by water, the inside of it is completely dry. As sea level continues to rise, we'll need more creative adaptations to protect our coastlines. Understanding how water levels are changing are just a first step to a resilient future.